Hello everyone, good evening to all of you. Welcome to you all on IMS Gate Academy. In this session, we are going to discuss the Gate 24 instrumentation exam analysis as well as detailed solution. So you guys first of all confirm audio and video so that we can start the session. We have some memory based questions also. So we will discuss the complete detailed solutions of those memory based questions. If you have also written the GATE exam instrumentation, you can also share your experience in the chat box. And if you are from EC or EE student, you should watch this session because many subjects are common as far as instrumentation W or EC is concerned. So what you need to do, just share the session if you are from EC Electrical Iron. My dear student, we'll discuss about some questions. I have one questions of signals, one questions of even control also. But before that, just a quick look on the subject wise mark weightage from the last 5 years. 2019, 20, 21, 22, 23, if I will check the weightage of the marks, then here student you can see aptitude mathematics is generally fixed like 15 or 13 around. Network theory was 9 marks. In GATE 23 I am asking right now. Chetan, everything is fine sir, good. Okay, very good beta, very good. So now students, signals and system 11 marks asked in the last year. Let's see how much marks in this year. Network theory 9, control 8, digital 9, analog 12, measurement of course 8, sensor 8, optical instrumentation 2 marks, communication 3 marks, electrical machine 3 marks, and electricity and magnetism is 1 marks. Okay. चलिए बच्चों, so let's start the variety of question, pattern of question that has been asked in the last year. Last 23, these are the other data. You can also see the data. MSQ was only 1, MCQ 31 and NAT 33. This is all about the data of the last year, GATE 23 instrumentation. Now let's talk about GATE 24 exam analysis, instrumentation engineering. Today is 4th Feb, exam conducted at 2:30 to 5:30. Okay, and now we are discussing here. So out of 65 question, whatever data that we have collected till now, according to the students, MCQ 46, NAT 18 and MSQ was 1 only. Okay guys, so I am solving the first question here and that is from signals and system. So I am solving the first question. I am solving the first question here. Let me take the brush here. 4, here also 4. So now we'll solve this. So first question that I have, the transfer function is given to you. The questions is from signals and system. The questions is from signals and system subject. And it look like very easy question from Laplace transform. If I talk about the topic name is Laplace transform. And if you guys attended my class, you can easily solve this question. It is based on the basic ROC concept. It's based on the basic ROC question, and the question is what? The transfer function is given to you. The question, transfer function is given to you, and that is nothing but T of S equal to 1 upon S square plus 13S plus 42 plus 13S plus 42, 13S plus 42. This is the question guys given to you, and ROC is also given to you, that is ROC given. And what was the ROC? Sigma is greater than -7 and less than -6. This was the ROC which is given to you, and examiner is asking for the inverse Laplace transform of this. Just confirm this question beta, just confirm the data of the question if you attended the last class, attended this paper, sorry. If you attended this paper, instrumentation, then just confirm this data. Okay, so what you need to do such type of question, first you need to take the partial fraction, and you should know the standard form of, yes, already covered this question, yes. So I have one control question also guys, I will cover this. So student, if I talk about the standard form, I hope you remember. Let me take the box here, let me take one box here. So student, if you attended my classes, only 2 standard form that you need to remember. E to the power minus AT UT, Laplace transform is nothing but 1 upon S plus A, and this ROC sigma is nothing but greater than minus A. I told you many times this UT representing the right sided, and right sided means ROC is greater. किसके greater? ROC should be greater than multiple of t. So here ROC sigma is greater, किसके greater? T के multiple, sigma is greater than minus. This is the standard form for the right sided signal and this is the standard form for the left sided signal. E की power plus at u of minus t. So when you will take its Laplace transform, you will eventually get 1 upon minus s plus a, and in this case the ROC sigma, because this is the standard form for the left sided signals, so ROC will be always less than and less than of the multiple of t, so sigma is less than plus. So these are the two standard form. If you remember that, you can directly take you are just left with the partial fraction and inverse Laplace. So when you will take the partial fraction, of course easy here because partition is easy here, so you can make it s plus 7 as well as s plus 6. Then you will open this s square plus 7 plus 6 13 and 7 6 ja 42. Student, here when you will take the partial fraction directly s plus 7, you should write like this, s plus 6 write like this. Now we are looking for the coefficient a just above the s plus 7. So s plus 7 you need to hide, and when you will equate s plus 7 equal to 0, so root of s plus 7 is s equal to minus 7. Minus 7 you need to put here, minus 7 plus 6 minus 1. So it will be minus 1. S plus 6 equal to 0, so s equal to minus 6. When you will write here, you will get plus 1. Now what you need to do, ROC is given to you guys. ROC is given to you, so you should make the ROC diagram as well. You should make the ROC diagram as well. So I am making the ROC diagram here. I am just making the ROC diagram here also. Yeah. So guys, just let me know if this is my ROC diagram, how many poles I have. I have two poles. One pole is at minus 6. Let me take minus 6 here and let me take minus 7 here. These are the two poles I have. These are the two poles I have. I hope it is clear. Now student, one line is at minus 7 and one line is at minus 6. And what is the desired ROC? The desired ROC is ROC should be greater than minus 7. ROC should be greater than minus 7. It means this region, yes. And ROC should be less than minus 6 means it means this. It means we can say that it contains a rectangular strip in the S-plane. It contains a rectangular strip in the S-plane. You know that it is S-plane sigma j omega S-plane. It means it is a both sided signals. And even you can comment on the stability as well as the causality also. It is non-causal because both sided, and of course it is unstable because ROC does not include imaginary axis. Bolo bachcho yes or no? Now you just need to take the inverse Laplace, but you have to satisfy the ROC. So s plus minus 7, s the pole, the term which will give you minus 7 pole, it should be right sided, sir, and it should be left sided, sir. It means s plus 7 wala term should be right sided, sir, no change, and s plus 6, this term should be left sided, sir. Okay, so here no need of precaution, directly you can take, so minus e ki power minus 7t ut because it is right sided. But because it is left sided, you have to take precaution. We have to convert into 1 upon minus s plus form. So when you will take minus common here, you will get this term 1 upon minus s minus 6. And now for this term, you can take the inverse Laplace. So I am writing from here. After that, I am writing from here because I don't have space. So first term will remain same. First term will remain same. It means what, guys? First term will remain same means minus e to the power minus 7t ut as it is, and next is also minus sign minus, and now you can take, so it will be e ki power minus ka 6t u of minus t. Just confirm that, guys, this is the correct answer. Whatever option is given, this expression should be correct. It means both sign negative, e ki power minus ka 7t ut and minus e ki power minus 6 ut. This should be the answer for this question. Just confirm, beta. Chetan, all of you just do reply fast. If you guys able to listen carefully, if you are properly, then just do reply fast. This is the very easiest question, I think. This is the very easiest question, I think, from signals and system. Just confirm if you guys attempted the today's instrumentation paper. Just share the link of the session. And if you are from EC Electrical Iron, those who have the GATE exam on 11th Feb, this instrumentation exam analysis as well as the detailed solution is very important for you guys. So don't miss it. Chale guys, I have one more question. The subject from signals and system. Subject from again signals and system. And the topic name is Nyquist rate. If I talk about the topic name, that is Nyquist rate. And it is very easy question, student. In our classes, we have solved these type of question in the second example. Okay, sir, it is positive of e ki power, Mohan, sir, is it positive of e ki power 7? No, e ki power minus 70. E ki power minus 70, na beta? E ki power minus, because plus sign, so it is minus e की power minus का 70 ut, and here is because of minus sign inside, so minus e की power minus का 60 ut. Everywhere sign is minus only guys, sign is minus only बच्चों. Mohan right sided is this beta, minus 7 is right sided, so no problem, no need of precaution. So minus sign already outside and just 1 upon s plus 7 का inverse Laplace, 1 upon s plus 7 inverse Laplace, अरे 1 upon s plus a inverse Laplace, s plus 7 just a replace with 7, so e की power minus 70 ut. That's it. Here is ut, here is u minus t, that's it. I hope it is clear to you. Mohan beta, yes. Chaliye, easy question, come on. Now what is the next question? That find the Nyquist rate of, find minimum sampling frequency or Nyquist rate, find Nyquist rate of xt, whatever data we have till now. Some students are saying it is sine square. You just confirm guys whether it is sinc square or sine square. Sine square 200 pi t, sine square 200 pi t. So student, what you need to do if such type of question is, why it is very easy, because we know that sine square theta is nothing but 1 minus cos 2 theta upon 2. So you can write here 1 minus ka cos of 400 pi t upon 2. Now we are looking for the FM, because we know that in simple, if the cutoff frequency of low pass filter is not involved and not given, then simply Nyquist rate is minimum sampling frequency, and it is provided by this formula. Nyquist rate is nothing but twice FM. So right now you just need to focus on FM part. So omega m is given to you. Omega m is nothing but 400 pi. Omega m is nothing but guys 400 pi, and we know that the relation between omega and f, because we know that omega m is equal to 2 pi fm, 2 pi fm. So from this we can say that the fm value is nothing but omega m upon 2 pi, omega m upon 2 pi. So just need to divide here with 2 pi. So fm is nothing but, when you will divide 400 pi upon 2 pi, so eventually pi get cancelled and you will get the 200 hertz. So 200 hertz, this is the value of FM, but because we are looking for the Nyquist rate, so Nyquist rate is nothing but what guys? Now the Nyquist rate will be twice into FM, and FM is itself twice 200 hertz. So final answer is nothing but guys 400 hertz. Just confirm student, just confirm the data for this question. Just confirm the data for this question. Khan online, yes sir, clear. Chaliye. So I have one more question from the control system. First you need to confirm these two question data. These two question data just need to confirm guys whether all the two questions data is correct or not. And if you are attended my classes, this is very easy questions guys, very easily you can solve. Yes. Do reply yes or no. Chaliye. So now student, one more question I have from subject. If I talk about subject name is control system, and topic is steady state error. Topic is steady state error. Steady state error, yes. Or you can say time domain analysis. What was the question actually? I think the diagram is given to you just like this. You just need to confirm the diagram also guys. All you need to confirm the diagram. Okay, just confirm the diagram. Just confirm the diagram whether this diagram same diagram is there or not. Just confirm this. Just confirm guys. Okay, so here we have plus minus sign, and I think the question is 1 upon s into s plus 1, this is gs given to you, 1 upon s into s plus 1, and the feedback is k given to you. This is r of s, this is r of t Laplace this, and this is your c of t output, and the Laplace is nothing but c of s, yes. And what examiner is asking, I think examiner asking, find out limit t tends to infinity rt minus ct, I think this is the question guys, do reply. Just confirm if this is the question, then just confirm it. We have solved such type of problem in the classroom. Khan online, do reply fast. Do reply fast, bachcho, do reply fast. Chali. So student, if this is the question, then simply what you need to do if such type of question is there, first of all student, we know that limit t tends to infinity means final value theorem, of course sir. And if I will take the final value theorem, if I will take the Laplace transform, then the limit of this value is nothing but limit s tends to 0 s into whatever the Laplace transform of this. So what is the Laplace transform of this? Nothing but r of s minus c of s. And if I will take common outside, limit s tends to 0 s, if I will take common outside r of s, then it will be 1 minus ka cs upon rs. 1 minus ka cs upon rs. And do you know the cs upon rs is nothing but CLTF, is nothing but the closed loop transfer function. And I hope many of you directly remember this CLTF formula also. If you attended my class, we known as CLTF formula. So in CLTF formula, what I am saying guys, shall I write first of all closed loop transfer function? And you know that closed loop transfer function is nothing but gs upon 1 plus g of s and h of s. And because here the values are given to us, gs value is nothing but 1 upon s into s plus 1, upon, this is gs, 1 plus gs hs. So again 1 upon s into s plus 1. So what is this? Gs upon 1 plus gs, hs is what guys? K. So when you will take the LCM now, s into s plus 1 get cancel out. So ultimately numerator will be 1 and here you will get s square plus s plus k. Just do reply fast bachcho, yes or no. So don't you think this is your CLTF? This is your CLTF, is this clear? Now just put the value of CLTF here, just put the value here. So when I will put, I will get limit. Even in the next slide also I can put because I don't have space here. So I am using the next slide, I am just writing the again formula. Here ESS will become limit s tends to 0 s r of s and 1 minus CLTF, 1 minus CLTF. Now I've just put the value guys rs because of step input I think given to you. I think step input given to you, yes. Input value given as a unit step. So r of t is given as a u of t step input. Unit step input is given to you. Unit step input is given. Unit step input is given to you. Yeah. So because of unit step given, we know that r of s value is nothing but 1 by s and 1 minus CLTF is nothing but what guys? CLTF is nothing but 1 upon, tell me, 1 upon s square plus s plus k. So 1 upon CLTF is s square plus s plus k. So just need to apply this because ss get cancel out. So you will get limit s tends to 0 and just take the LCM here. So it will be s square plus s and plus k minus 1 upon s square plus s plus k. So when you will directly put the values wherever is s, just put 0. So this is 0, 0, 0, 0. So the final answer should be k minus 1 upon k. Just confirm this bachcho. Just confirm this, whatever the option in which k minus 1 upon k is there, it is the only correct answer. It is the only correct answer. Just do reply pyare bachcho, is this clear or not? Just do reply pyare bachcho, is this clear or not? Till now, are you guys matching with the data? Are you guys matching with the data? Yes, I think now voice is clear. So now I would like to invite Vipin sir. So he will solve some questions of machine, I think. Yes?
Sir. Okay. Machine, and one question I have received from EMFT.
EMFT also.
Yeah.
Okay, okay. So according to you, whatever questions you have just collected, what was the level of
Sir,
overall exam?
I have received the feedback from student and they are saying that the paper was not an easy one, but they felt that it was a moderate one.
I think now voice is clear. Moderate to tough. So now I would like to.
So once we will receive all the questions, we will be able to judge actually what is the type of level of questions were there. Okay. So student, how was the exam? Those who are there in live, can you just comment what you felt? How was the level of the paper? What feedback I have received is the paper was a moderate one. student felt that it was not an easy one. Okay. So how are the subjects like machine and EMFT? I have questions from machines. Okay. So let us discuss the questions from machines. So just see this question, both the questions from machine, they were very easy. Okay. One I have from induction motor and the second one that I have is from transformer. Let us discuss the transformer question first. So what has been given in the transformer question is that it was a single phase transformer having 50 kVA rating. So the rating of the transformer was given 50 kVA and it has an efficiency of 95% at full load unity power factor. So the efficiency, if I write efficiency to be neta, it was given at full load. Okay, so at full load and unity power factor, the efficiency was given to be equal to 95%, means 0.95. We will do all the calculations in per unit. Okay, that will simplify the things when it comes to efficiency. So calculations we can avoid. Now what we have to do, see this was given to us, and what we have to do, we have to find the efficiency at 75% of the loading. Okay, and when power factor is 0.8, power factor is having a value of 0.8. So we have been given the efficiency at full load unity power factor, which is 0.95. We have to calculate what will be the efficiency when the loading is reduced to 3/4, means 75% at 0.8 power factor. This is what we have to calculate here. Okay. So you know what is the formula that we have to use. So the formula in case of loading, if we include the load factor, the formula is, let me call the load factor to be x. Okay. So x into cos phi divided by x into cos phi plus, this is output plus losses. So how do we write losses? X square times P copper full load plus the iron losses. Okay, so this is the formula. This is nothing but actually the output over input, and input consists of output plus losses. Okay, so just see the load factor. What is x here? X is basically the load factor. Okay, we will do all the calculations in per unit, and it was given that Pi value is 0. No iron losses were there. This was given to us. So let me assume that S equals to 50 kVA. Okay, that is 1 per unit for us. Let us assume that. So if we apply all these conditions here, just see what will happen. If we apply the first given condition in which the efficiency that we have is x, what is x? Full load. Full load means we will take the value of x to be 1. S is 1. Cos phi is 1. Okay. So divided by, again this, the same thing we will be writing here. Okay, let me write x here. We forget to write x here. So this will be 1 again. Okay. All these values will be 1 again here. Plus iron losses are given 0 and x square will be 1 plus P copper, or yes, P copper losses full load, and this is given 0.95. So just see in this equation there is only one unknown, and which is the copper losses. So once you will find copper losses from here, okay, the copper losses will be equals to 0.05 per unit. Okay, 0.05 per unit. Now again apply the same formula. So once you will apply this formula again here, so neta you have to calculate. Okay, neta you have to calculate at 75% loading and 0.8 power factor. So you have to calculate this for this loading. So what will be the x value? X value will be right now 0.75 into S, we have assumed 1, power factor is 0.8. Now repeat the same data in the denominator, 0.75 into 1 into 0.8 plus iron losses are 0, and right now what will be the x square value? It will be 0.75 square, and copper losses as you have calculated is equals to 0.05. Okay, so just see, we have written all the values here. Okay, now when you will solve it, you will get an answer of 9.9554. Okay, 0.9554 means 95.454 percent. So this is how you have to solve this question. Okay. So this was a very easy one. Everybody know that there might be a question from the efficiency relating the load factor. Okay. So this was the expression. If you know this, you could have solved this question very easily. So how many of you were able to solve this question, and how many of you are getting the same answer as well? Okay. I think in the class when we met, I told you that there might be a question related to this particular thing. And for electrical students also, those who are going to appear next week in the exam, this might be a learning for you. You may also get a question related to the same pattern in the exam as well. Okay. So I hope you were able to do that question. Now the second question that I have is related to induction motor. Okay. So what has been given in this question is, so this is the second question that was from electrical machine again. Okay. And in this question what has been given to us is, we have the data in which we have, it was given that it is a 3-phase induction motor. Okay. So it was 3-phase induction motor, and we have the ratio of starting torque to full load torque which is equals to 1. So we have been given that the starting torque is equals to 100% of full load torque. That means starting torque is equals to full load torque. Starting torque is equals to full load torque. Hello Raju, have you solved that question of machine? And the maximum torque is equals to 300%. We have been given that the maximum torque is equal to 300% of full load torque, or we can write it 3 times TFL. Okay. My answer is 95.30. range में आएगा क्या? बिल्कुल आएगा. Okay. This question will definitely come into the range. They will give range like, they will give you a range like 95 to 96, anything in between 95 to 96 is acceptable. Okay. So have confidence on yourself. What you have done is absolutely correct, Raju. Fine. Anything coming between 95 to 96 is acceptable for that. Okay. Very good. You were able to solve that question. So what has been given in this question? We have 3-phase induction motor. Starting torque is equals to full load torque, and maximum torque is equals to 3 times full load torque. Why they are giving this relation? Because we have a very important relation between starting torque and maximum torque. So the starting torque to maximum torque, we have a relation that this is equals to 2 times Sm over Sm square plus 1. Okay, what is Sm? Slip at maximum torque. Okay, and this is what we have been asked. We have to calculate S of M. What will be the value of slip at maximum torque? Okay. Raju, just confirm whether this was the question. All the data are correct. Okay. You have been asked the slip at maximum torque, and the answer that you have to give in percentage. Okay. This is what we have to do. We have to do here. Why they have asked this question? Because we have a very important relation between starting torque and maximum torque. So they just wanted to know whether you are aware of this or not. So guys, we have a relation between starting torque to maximum torque. Just see. If we just divide these two equations, okay, so what will be the starting torque to maximum torque ratio? This will be 1 by 3, isn't it? This will be 1 by 3. Now come back here and put the values. So when you will write this ratio to be 1 by 3, and this is 2 Sm over Sm square plus 1. Okay. So just see, we have one equation here which we have to solve. So what will be the quadratic equation? This will be Sm square minus of 6 Sm plus 1 equals to 0. Okay. Now when you will solve this equation for Sm, what you will get? When you will solve this equation for Sm, you will get 6 plus minus under root 36 minus 4 divided by 2a, or 6 plus minus under root of 32 divided by, what will be the value of a here? It is 1, okay, by 2. Now if I will accept positive value here, then what will happen? My answer will be greater than 1, isn't it? So if I am accepting a positive value, I am getting two answers here, 5.85, 825, or if I am accepting negative value, my answer will be 0.175. Now which one to take? Slip can never be greater than 1, isn't it? So just see, this is the answer that you have to take and this you have to neglect. So what is the answer here? Slip at maximum torque, it is 0.175 and the answer that you have to give is in percentage, so it will be 17.5%. This is how you have to solve this question. So Raju, were you getting this same answer here for this question? Tell me Raju, you are getting the same answer for this question? Tell me students, is there any mistake in the data of the question? If there is any mistake, you can just let me know so that I can correct and give you the right answer accordingly. Okay. So was it correct? And were you getting 17.5% as the answer for this question? Okay. Now next question that I have is from EMFT. Okay. And it was a very easy question from EMFT. But what happens with EMFT that most of us used to just simply see the questions of EMFT and used to ignore it, isn't it? But it was a very easy question. What is given to us is in a cylindrical conductor, okay, my slip was 0.215. Data is correct, Raju? Is there any problem with the data? Just confirm me. All the data was correct? Then I think you have mistaken in the solution, okay. Now, the question that I have from EMFT is, in a cylindrical conductor with a cross-sectional area A, okay, so what type of conductor we have? Cylindrical conductor, okay, cylindrical conductor of cross-sectional area A. So the cylindrical conductor that we have is having a cross-sectional area of A. The current density is J equals to Kr square. So we have been given the current density and the current density is given J equals to Kr square, where R is the radial distance, okay. R is radial distance. R is radial distance, it was mentioned. Now what we have to do, find the current in the conductor in radial direction, okay. And it was given that R is varying from 0 to A, okay. So what we have to do, find the current in the conductor. Find the current in conductor, okay. Now whether this was, sir, calculation mistake, okay, no problem. Now Raju, just confirm whether this is correct, what data I have written here is correct. Is this data correct? And whether this was an object MCQ question or it was an NAT question. I think this should be a MCQ question. Okay. Anyway, so what we have to find here, the current in the conductor. So how to calculate the current if the current density is given to us? So the current is surface integral of J dot ds, okay, J dot ds. Now what will be the ds? So you can see that R is varying from 0 to A, means we are taking radial direction, okay. So cylinder, just imagine this is a cylinder and we are taking the radial direction. Radial direction means Z equals to constant surface, isn't it? Radial direction means Z equals to constant surface. Just see. So we are taking Z equals to constant surface. So if the Z equals to constant surface we are taking, then what will be the value of ds? Then it will be J, okay. Then this integral will become J. What ds we will take? Ds that we have to take will be dr, okay, R is varying, and r d phi, okay. If we will consider this plane like this, so what we have to take here? Dr and r d phi, okay. So once you will do that, it will become what? It will become J dot ds. So just put the value of j is given k r square, and ds when you will write, it will become, okay, it will become r, and we have r dr d phi. It will become r dr and d phi. Okay. So just see, k is a constant, and if we will integrate with respect to phi, phi will vary from 0 to how much? 360. So we will get 2 pi for it, and then we have only r to the power 3 dr remaining. Okay. So what we will get? We will get 2 pi k, and r is varying from 0 to a. So the limit for r will be 0 to a. So 2 pi k, and it will be r to the power 4 by 4. Limit will be 0 to a. So once you will put the limit, it will be pi by 2, k pi by 2, r to the power 4 or a to the power 4. Okay, k pi by 2, a to the power 4. सर EMFT का भी एक गेट स्कोर बूस्टर विथ फॉर्मूला सेशन करा दो, डबल ई वालों को हेल्प हो जाएगी. ओके राजू, वी विल ट्राई. ओके, बट कन्फर्म मी वेदर दिस वॉज, सो आंसर इज दिस, and I think this should be an MCQ type of question. Was it? It was an MCQ type of question. Raju, just confirm me whether this was an MCQ type of question. Okay, so 2 questions from machine and 1 question from EMFT that I have discussed. Those were really easy questions. I don't think you people must have struggled here. Okay, most expected questions. Whatever topics are important from machine and EMFT, they have really asked questions from them. Okay, so overall difficulty level, as the feedback we have received from students, they are saying the paper was a moderate one. Okay, and the machines questions were easy, and students what they have seen is the maths and aptitude questions were easy. So it was an MSQ question. Very good. So this was an MCQ question, but we don't have options. So I think this option, whatever is the number of this option A, B, C, D, that will be the correct option. Okay. So maths and aptitude, they were very easy. Was it so? And signal control, they were also not difficult. Easy questions were asked from signals and digital, and there was a question from analog from op-amp. I think students have found that that question was not an easy one. Okay, just a second. JP sir. So student, this is all from my side. The question that I have received from machines and EMFT, I have just solved those questions. If I will receive more question, I will be there. Okay, now I am calling to Gopal sir, and he will discuss questions of network, analog. Okay, network and analog. So Gopal sir, please discuss questions of network and analog.
Hello students, welcome to IMS Academy. I would like to do initially problems from the analog circuits, then after I will do network theory also. A problem is given from the MOSFET, that problem I will give and I will do. This problem is given so simple. The problem is given like this. In a MOSFET circuit, if VDD equal to, VDD is given here, VDD equal to 3.3 volts, 3.3 volts, with the RD equal to drain resistance is given, with the drain resistance equal to 3.3 K, 3.3 kilo ohms, this one. This value is given 3.3 kilo ohms. With a source ground, source is grounded here. With source ground, no voltage connected to drain circuit. No voltage connect to drain circuit. Drain circuit. Drain circuit. And here given drain circuit in saturation. But mostly it is required the data will understand now. If saturation, if mu n COX is given, here 250 micro, 250 value is given, 250 here, 250 micro, what are the units that you put it, understand now. And also it is given W by L is given 4, and threshold voltage is given 0.65 volts. This is the given problem. But is asking to find, what value is asking to find? Is asking to find the drain current. Find drain current. I will put directly ID. It is required in microamperes only. Is asking to find in microamperes. This is the given portion. But in this problem, what you have to do, you need to draw at first the diagram. If you have drawn the MOSFET diagram, you can get the required answer here now. The MOSFET is drawn in this way. There is a MOSFET here. This is connected to the ground. Supply voltage is given 3.3 volts and RD is given 3.3 K. I will put here now. This is the solution I am writing here now. This is the solution. RD is given 3.3 K here, and supply voltage is given 3.3 voltage. In the problem it is given strictly it is in saturation. If it is saturation, directly drain and gate is to be connected directly. This shorted only here now. This VDS, this is the VDS value. From here to here, this is nothing but the VDS value. This is the drain voltage. From here to here, VDS. VDS and VGS will be same whenever it is in saturation. That point we know very well. But in this case, I need to find out the drain current. Direct formula I can apply. 1 by 2 into mu n COX. W by L. There is a formula when it is in saturation. VGS minus VT whole square. Threshold voltage whole square. Now, I can substitute all the values are given in the problem. Drain current I want to find half into mu n into COX is given 250 micro. 250 into 10 power minus 6 is given. W by L is given 4. VGS, from here to here voltage is to be taken as a VDS only now. So I can write VDS equal to VDS equal to this minus this. 3.3 minus current passing through 3.3 K is nothing but ID. This current is a ID. So 3.3 minus drop across 3.3 K is nothing but drain to source voltage only. Drain to source voltage or drain voltage both are same only now. Here I can write directly 3.3 K into what is now ID is to be taken here now into ID. The VDS is equal to VGS only now. VDS and VGS are equal when it is in saturation region. This is equal to VGS I can put directly. Now I can find the required value of the drain current. VGS is given, we got as a 3.3 here, minus 3.3 into 10 power 3 into ID, minus threshold voltage. Threshold voltage is given directly 0.65 here now, 0.65 volts. Whole square I can put now. This is whole square. Expand it and find the value. If you are finding the value here, I am not going to expand, it takes a time only now. That's why I will put directly drain current. The drain current you are going to get, that value will be around 500 microamperes possible. This current is possible 500 microamperes only now. 500 microamperes of current is possible. This is the solution for this question now. By using the MOSFET, the problem can be done. And I wish to give the rest of questions are given by using the operational amplifier in the analog. By using the op-amp, 1, 2, 3 problems are given around. Those 3 problems I will do. You will understand clearly. The next problem here given is find V01. Directly I am writing now. Find V01 and V02. 2 values are required here now. And here the op-amp is given like this. There is an op-amp is a minus and plus. This is connected to V01. This positive terminal is connected to the ground. This terminal is connected to the ground. This terminal is connected to the ground. And here connected with a voltage. This is connected with voltage. That voltage is given 1 millivolt. This is given 1 millivolt. And also here connected with a resistor R. A resistor R. And this is connected to the ground. And also here given a resistor R. Here given resistance R here. This is R. And this is connected to the one more resistor R here. And connected to the one more op-amp. This is one more op-amp. This terminal is connected to the ground. This is V02. Here given resistance of R here now. It's a very simple question. I hope anybody can do this question easily now. Understand now. But in this case, I can say this node voltage is equal to how much? If I ask, anybody can say this voltage is equal to 1 millivoltage only. This voltage becomes 0 voltage this side. Here it is possible 1 millivolt only now. 1 millivolts possible. That voltage. By using the nodal analysis, I can find the V01 value. But when diode, when op-amp is ideal condition, V plus and V minus are same. This is the positive terminal is given 0. This potential becomes a 0 voltage only now. But what are the currents are going to flow? This current according to nodal, this current plus, this current plus, this current equal to 0. This current equal to 0. It doesn't flow any current this side. Impossible then now. Then I can write the equation like this now. 1 millivolt minus 0. 1 millivolt minus 0. I can write 1 minus 1 by R. Finally, the values we can get in millivolts will now. 1 minus 1 by R. I can put here now. Solution like this now. This current 1 millivolt by R. I can put now 1 milli by R. 1 milli minus 0 by R as per nodal. Plus this current is nothing but 1 millivolt 1 into 10 power minus 3 minus V01 divided by R here. I can get R. And the next current it is going to flow this side. 1 millivolts minus 0. I can write 1 millivolt minus 0 divided by R I can put now. Summation of all these currents equal to 0 as per nodal. You try to R value will be cancelled directly, and finally V01 you are going to get this V01 will be 3 millivolts here possible. 3 millivolts possible. Yes, this is the value of V01. And the next one there were required V02 value also. How we can find V02 value? But this network you watch how it appears. It is just like a what? Ideal this is nothing but the scale changer or inverting operational amplifier one now. So V02 I can get by using the inverting operational amplifier. I can say V02 I can calculate by using the minus of R2 by R1 into this input voltage R by R from the inverting operational amplifier into this voltage a 1 millivolt. RR here cancel. Finally, what voltage you can get here now? This is nothing but minus 1 millivolts it is possible. Minus 1 millivolts possible now. These are the values of V01 and V02. And I wish to give one more question here now from the operation by using the operational amplifier here given. I would like to give in your hand. This problem is given directly. I am drawing the circuit only now. Here given the circuit like this. There is a circuit in this form by using the op-amp. This is connected with a negative terminal. This is a positive terminal is connected to the ground. and here it is connected with a resistor R, and it is connected with a supply voltage V in. V in voltage is given here now. And there is one capacitor, that capacitor is given here now 0.1 microfarad, 0.1 microfarad here now, this capacitor. And the resistance of 1K is given here now, this is 1K is specified. And also here given, this is RF, one more resistance is connected here now, RF. This is R suffix F. This can be taken capacitor C only now. And this voltage is nothing but the V naught. In the problem it is given DC gain is given in the problem. DC gain is given minus 10. And also it is given in the problem, but is asking to find 3 decibel bandwidth. 3 decibel bandwidth equal to how much? This is the requirement here needed only now. How we can calculate? By using this network, is asking 3 decibel bandwidth only now. If you want to find the 3 decibel bandwidth, you need to find the voltage gain from the given network at first. 3 decibel bandwidth we can get only from what now? Overall gain only now. So V0 by V1 I can get like this. V0 by V1 I can get in this form. I want to find the overall gain for the given circuit. The overall gain is nothing but the V0 by Vi. This total impedance is available here is a Z2 value. This total impedance is nothing but this Z1. The gain is nothing but minus Z2 by Z1 we can use directly. Minus Z2 by Z1. By using that formula we can find. Just like an inverting operational amplifier I have taken here now. And there I can write Z2 is nothing but minus of, these two are in parallel. RF is parallel to the what? RF into 1 by CS divided by RF plus 1 by CS I can get now. This is Z2. Z1 is nothing but 1K. I can write directly 1K here now. Zk is nothing but the 1K is possible now. And simplify this V0 by V1. If you are simplifying this one, you will get minus RF by R into, this is nothing but the R we can put otherwise best. This way you can put in terms of the R. Finally we can substitute the values. This is R. On simplification we can get R into 1 plus SC into RF is possible. This value is possible here now. This is the overall gain of the what now given operational amplifier. By using this operational amplifier, from this we can get now minus RF by R1. Minus RF by R1 is given in the problem. DC gain is a minus 10. DC gain is nothing but the minus RF by R. Minus RF by R is the DC gain. So I can put minus RF by R equal in the problem it is given minus 10. Thereby required RF value. RF equal to what I can put here now? RF equal to 10R. In the problem R is given 1K. 10 into 1K. And finally it becomes a what? 10 kilo ohms only. 10 kilo ohms is possible. That is RF value. By using this RF value we can find 3 decibel bandwidth is asking to find. 3 decibel bandwidth is required. 3 decibel bandwidth equal to, you know very well, 1 by 2 pi C into RF. That formula we are going to use. By using this 3 decibel bandwidth is calculated. We can get 1 by 2 pi. The capacitance of the capacitor is given in the problem. How much it is given? 0.1 microfarads. And RF we got as a what now 10 kilo ohms, 10 into 10 power 3. And if you are using the calculator, its value will be 159.15 hertz is possible. This is the required solution for this question. Yes, this is second, and next one I want to give here now. One more question is given here like this now. I want to give one more problem here now. By using the operational amplifier, it is given one more question that I want to give in your hand. Please try to understand this question. Directly I am giving this circuit here now. It is given here, there is an op amp This is connected to the capacitor. The capacitance of the capacitor is given 10 nanofarads. It's given 10 nanofarads here now. That value is given 10 nanofarad. Maximum, okay, this is given as a what now? 10 nanofarad now. And also given 1K resistor here now. The resistance is given 1K, 1 kilo ohm it is given. The output what we are getting here is a V0 value. And here it is given resistors like this now. This is a 16K, this is 16K, this side it is given 10K. This is connected to the what now? 10 kilo ohm and 16 kilo ohms it is given. These two are connected together. Like that it is connected here now. And also the waveform is given. What is the name of the circuit? And watching this circuit you can identify. This is an Astable multivibrator. From this Astable multivibrator, what you will get now? Square waveform. What now? If you are giving the any square waveform, you are going to get the what now? But what now? When the sinusoidal waveform is given, means you will get the square waveform, you know very well now. But it is given here now. But it is given here now. But it is given in the problem. This is the square waveform is given. Square waveform given like this now. And here it is given, you are going to get the shape of the shape is possible like this only now. This diagram is given. This total voltage is given 13 voltage. This voltage is given minus 13 voltage. 13 voltage. And also in the problem it is given, this is nothing but the VP only now. The waveform, how it is available, like now the capacitor is given here now. And the problem is asking to find the frequency of the waveform generated. Frequency of the waveform generated by these Astable multivibrators. You know very well, F equal to 1 by T, T equal to time for one cycle only now. T equal to time taken for 1 second now. That means what now? The frequency is calculated by 1 by T. The T is calculated by 2RC into ln of 1 plus beta by 1 minus beta. Generally, we are going to use in the Astable multivibrator now. The R and C values are given. R is nothing but the 1K, C is nothing but the 10 nanofarad, beta value is required here now. How we can find beta value? Beta I can get from this resistors only now. Beta is calculated by 10 by, according to voltage divider formula, 10 by 10 plus 16. 10 plus 16, their applied voltage divider formula beta. But here the beta value it comes as 5 by 13 mostly. 5 by 13 is possible. By using this data we can find the what now frequency directly. And T value directly you put it here now. F equal to, I want to substitute. T is nothing but 2RC, directly I am writing now. 2 into R is nothing but the 1K. And capacitance of the capacitor is given 10 nano. 10 into 10 power minus 9. And ln of 1 plus beta is nothing but the 5 by 13 here divided by 1 minus 13. 1 minus 5 by 13 you can use. Use the calculator, you are going to get the frequency here now. The frequency of the waveform here generated is 61.657 kilohertz is possible. Kilohertz is possible. That much frequency is generated by this Astable multivibrator now. This is the problem is given here now. So these are all the problems from the analog I got it. Now one network problem I got it now. That is from the, I will give you now, you can understand clearly now. A problem is given like this now. If two coils are connected, if two coils are connected by using the inductors, it is given problem here now. If the two coils are connected in aiding inductance, it is given 500 millihenry. 500 millihenry it is given. That much value is given. 500 millihenry is given now. And opposing connects opposing connects 300 milli opposing connects 300 millihenry, it is given. 300 millihenry is given. If self-inductance same, the problem it is given, self-inductance same only. When the self-inductance is same, is asking to find coefficient of coupling. Find coefficient of coupling. Coefficient of coupling is asking to find. Coefficient of coupling is required. This is the given problem only now. But easy problem is given, a very simple question. Anybody can tackle it. It doesn't take a time or the more also here now. But I will tackle this question. How I am going to tackle this question, you please watch it here now. In the problem it is given, two coils are connected in aiding and inductance is 5 millihenry is given here now. But here it is given in the problem L1 plus L2 is given here. If it is aiding formula, you know, L1 plus L2 plus 2M equal to, it is given. At the time of aiding, it comes as a 500 millihenry. 500 millihenry given. Millihenry, this value you can put now. Into 10 power minus 3, we can put here now. And also here in the problem, it is given clearly. The self-inductance is same only it is given. Self-inductance same means L1 equal to L2, we can take now. That equal to some L, we can assume, no problem. So I can put L1 plus L2 means 2L plus 2M equal to 500 into 10 power minus 3. And thereby given what now L value is, but in the problem what is given here now, L value given or not given now. By using this we can measure what is L. And the, here the two, but it is given one of the equation we are getting here now. By using this we can get the one equation only now. But 2L directly it is taken means we will get now. Yes, that value possible. By one more is given here now, opposing is given. Opposing whenever it is given L1 plus L2 equal minus 2M equal to, I can put what is given 300 millihenry is given. 10 power minus 3 is given. In the problem clearly specified L1 equal to L2 equal to L itself now. I can write 2L minus 2M that equal to 300 into 10 power minus 3 its value. This I want to take it as a equation number 2. By solving these two equations, you can get L and M. Once you are getting the L and M values, you can find the coefficient of coupling only here now. If you are solving 1 and 2 values, you are going to get L value as 200 millihenry. 200 millihenry possible. And M value 50 millihenry possible. M value 50 millihenry possible. 50 millihenry possible now. Yes, we are getting L and also what now M values. Now coefficient of coupling is required. Coefficient of coupling is calculated by K. The K value we can get M by root of L1 into L2, we know very well. L1 into L2. Just substitute, you will get answer here now. You have to substitute the values only now. M value, but L1 and L2 equal to L itself now. I can write M by root L square I can get now. Root L square equal to M by L I am going to get here now. There you can substitute M value and L value. The K is nothing but the M is given 50 millihenry, milli cancel by 200. 50 by 200 I can put now. Finally, coefficient of coupling I can get 1 by 4 only now. Answer is 1 by 4 for these 4 K value. So these are the problems here now. But I hope you followed all the questions here now. But around the 4 questions are given from the operational amplifier. Understand now. But all are different models only now. Very good questions.
Yes. So hello dear students, welcome back. I think I have some more questions guys. So we'll solve that questions. Chali. So first of all you should confirm the audio and video so that we can start the session. I think the audio video is clear. Chaliye. So I have one more question, that is from control system. I am just writing the given data guys. The sub question is control system. Okay, and the topic is nothing but I think RH method or root locus I think. What was the exact question? The open loop transfer function is given to you. Open loop poles are given. Open loop poles are given. I am just writing the given data, that is at s equal to -4, -1 and 0. So definitely we can design my OLTF, open loop transfer function, is nothing but 1 upon s into s plus 1, s plus 4. These are the given data for us, okay. So what I am doing here, let me take this color, okay, now okay, everything okay, chali. So now tell me guys, in what examiner asking, ki root locus of this transfer function where unity feedback h of s equal to 1, even if you wish to make the curve diagram form, then I think this question is given to you. Whatever the language, this is the data, I just confirm with two student s plus 1, s plus 4, and here we have this hs1. So feedback is 1 here, and this is my r of s and this is my c of s. Yeah. So student asking for what? If I talk about the root locus, is the easiest question ever. Asking for where the root locus intersect the imaginary axis. Where the root locus intersect the imaginary axis. And if you are my classroom student, the root locus diagram you should visualize. You should visualize the root locus diagram without touching notebook and pen. Yeah. Without touching notebook and pen. 0. This is -1 and -4. So for sure the root locus diagram is nothing but this one and this. Yeah, this is the root locus diagram. This must be the root locus diagram. Yeah, it must be the root locus diagram, that you know that one is 60 degree, one is 300, one is 180 degree. And all these point k equal to 0, that we know. That we know very well, yes. However, such things are not required in the gate exam, but you know this. What examiner asking? Examiner asking ki find out the intersection point of root locus on imaginary axis, and the point is given as j alpha. So I think alpha value is asking for, examiner asking for the alpha value, yes. So student, in such type of question it is look like a root locus question, but actually it is a Rao-Hurwitz question. You have to write the characteristics equation first. So when you will write the characteristics equation, it will become 1 plus GSHS. So we multiply this s square plus 5s plus 4. Finally multiply with s, so s cube plus 5s square plus 4s plus, here we have the transfer function k is also there. So plus k equal to 0. This is your characteristics equation. And you attended my classes guys, you know very well what is the short trick. First of all student, because the pole lie on imaginary axis, so it will be marginally stable, so BC equal to AD. BC equal to AD means 5 4 the 20 equal to km. And we know that the point at which the root locus intersect on the imaginary axis is nothing but this auxiliary equation. And short trick says that auxiliary equation 5s square plus km equal to 0. So s square is nothing but minus ka km upon 5. And do you know what is km? Km value is 20. So minus ka 20 upon 5. So it is nothing but minus ka 4. S square equal to minus ka 4. So s equal to plus minus ka 2j. And when you will compare the alpha value, alpha is 2. So for this question, alpha or a, whatever the unknown, answer is 2 only. Answer is 2 only. If you don't know this method, just simply apply the Rao-Hurwitz, you can solve this. But according to me, Rao-Hurwitz is not at all required here, because if you attended my classes, this is the easiest question ever. Just do reply in the chat box, have you attended this question beta? Have you attended this question beta? Good evening Raju, sir, EMFT, okay. So control system question, just confirm this data. Just confirm with this control system question beta, yes. And again I am coming to one more question, that is steady state error questions. Whatever data you have given, we have already solved this. But again I am telling guys, if this is a question, this is very important, non-unity feedback system. Non-unity feedback system, I told you in the class also. I told you in the class also, most controversial. Whenever non-unity feedback system will come in the steady state error, it is a most controversial. Bolo bacha, yes or no? In 2014, last time in the gate, it was asked, and that time I told you there is a 3 different answers. But this time, sir, ROC question also completed with Ayush. Ayush, this is the ROC question we completed. Yeah. ROC question answer is this only. ROC question answer is this, minus 7 e ki power minus ka 70 minus e ki power minus 70 ut minus e ki power minus 60 ut. Now what I am saying guys, in this question, if this value is given to you, limit t tends to infinity RT minus CT, and if ET is given to you like this, RT minus CTA. Now I am telling you, many students, if you will solve this, you will get the answer k minus 1 upon k. If this is the only option, if this is the only term mentioned in the option, then of course this is the only answer. And if 0 is also mentioned in the answer, because whatever we have calculated here guys, this is nothing but the nice method, as I already told you in the class. Even in the nice method, you can convert the non-unity feedback to a unity feedback system also. I hope you remember each and everything that I already taught you in the classes. If you are my classroom student, even you can visualize. But the same question, if I want to solve by using the Kuo method, by using the Kuo method, yes, Kuo method, then the formula will become, the CLTF formula will become what? Limit s tends to 0, SR of s. If I am writing 1 minus CLTF, it is still nice approach. It is still nice approach. But in the Kuo approach, we have here KH. And do you know KH is what? KH is nothing but the non-unity. This is the DC gain of HS. And here the DC gain of HS is K only. So that is why here in this question, KH value is K. Why I am again solving there? Because some student says that, sir, in the option 0 was also there and K minus 1 upon K was also there. So K minus 1 upon K is correct by using the nice approach, but it is a challengeable question guys. It should be in the marks to all category also. Because if IITs, that is I am expecting that IITs will release the answer key na. In the answer key they will just give the answer K minus 1 upon K according to me. If they will give the answer, K minus 1 upon K, then definitely it's going to be challenged by using the Kuo approach, because Kuo is the foreign literature and IIT need to admit it. Okay guys, and it is a very authenticate and very famous literature. Okay. So here KH value K, so what I need to do? I need to do limit s tends to 0. S, what is RS? RS value is 1 by S. 1 upon KH value is K, and CLTF value is same sir. Ye 1 upon S square plus S plus K. 1 upon S square plus S plus K. Yehi to hai. Yehi. Now SS get 0 guys, SS get cancelled. Is it clear to you? Now what you need to do, you just need to do limit s tends to 0, just take the LCM. So when you will take the LCM, you will get K into S square plus S plus K. And finally here what you will get sir, S square plus S plus K, S square plus K and minus ka K. And finally when you will put S equal to 0, this is 0, this is 0, K get cancelled, so 0 upon something is 0, answer is 0. So one answer is K minus 1 upon K, one answer is 0. Student, if both are in the options, then it should be MTA. Then it should be marks to all. And if only one option is there, if K minus 1 upon K is there and other options are different like K upon 1 minus K, K minus 1 K upon 1 plus K, if such options are there, then of course this is the only answer. But if two answers are there, then definitely it should be a MTA, marks to all. Because nice approach as well as Kuo approach, both are the valid approach, both are the foreign literature. And we know that according to Indian literature, if you follow the Nagarath and Gopal and BS 1K, according to them, there is no difference between the unity and non-unity. Yes, I told you in the class also. According to that, the formula is only ESS limit s tends to 0, SRS upon 1 plus GSHS. But that is 100% wrong. And I know that you will not follow that approach here in the non-unity feedback system only. As far as non-unity feedback is there, only 2 scope is there. Yes. And I am telling you why I am telling you with confidence, because the same question one time asked in 2019 also. 2019, but not for GATE, engineering services, UPSC engineering services. Student, GATE में last time non-unity feedback system asked only in 2014. After 2014, after 10 years, gate to 24 today, the non-unity feedback concept again came in instrumentation. Before that, when 2019 engineering services question asked na, the UPSC given the answer according to the nice approach. According to the nice approach, they have given the answer. Yeah. So that is why I am expecting also ki gate IITs also, when they will release the answer key, maybe they will release this in their answer key. Maybe they will show k minus 1 upon k is correct answer, but it going to be challenged. Sir, किसका use होगा exam? That is why I am telling you, Raju Kumar, it going to be challenged. If the IITs will give the answer 0, then we can challenge the answer key by using this approach, this answer. And if they will show you, if they will give this answer, we will challenge by this. In the gate exam, guys, we have this we can say that scope to challenge the answer key. And we need to fill a form of, I think, 500 rupees DD. We need to send to them. And if your approach, you have to just send with some authentication proof also. So we can give the approach by nice approach or co-approach, like it. Okay. So no problem. I think complete explanation I have provided to you. Now I think one more question I have. So just to go for that. Okay. So I have one more question here. The question is like that: ki sinusoidal transfer function, the polar plot. Find a polar plot for that. Find the transfer function. Find transfer function where options are given A, B, C, D, and polar plot is given to you. Polar plot for a sinusoidal signal is given to you. Polar plot is given. And what is the polar plot shape given? Like some student told that this is the shape. This is the shape of polar plot. You know that polar plot is drawn in GSHS plane. Polar plot is drawn in G of S, H of S plane. So this is the real part of GH, and this is the imaginary part of GH. Yeah. Now student, here one value we have, and at that point, at this point, we have this, and this is the given to you. And at this point, I think omega equal to 0 given. And at this point, omega tends to infinity. Like that, omega tends to infinity. It is going downward. It is going downward like this. And options are also given to you. Options are 1 minus ka j omega t, 1 minus ka j omega t upon 1 plus j omega t. Option number B is 1 upon 1 plus j omega t. Option number C is 1 minus ka j omega t. And option number D is 1 plus j omega t. Yes. So student, how you guys can solve this question? Raju Kumar says that. Raju Kumar, I think I already replied. Very good, beta. 1 upon kh minus CLTF. Shabash. So by dear student, you just need to tell me here, because at omega equal to 0, your magnitude is 1. At omega equal to 0, at omega tends to infinity, you check the magnitude. At omega equal to 0, your magnitude is 1, that is constant value. And omega tends to infinity, your magnitude goes to minus infinity, negative excess. So here student, if I check about only one option will give me magnitude omega equal to 0 pe 1, and omega tends to infinity pe magnitude is also minus infinity here, because at that time this will one will neglect and omega infinity minus sign infinity. So option number C for Chennai Super Kings CSK is the only satisfy here. I hope this is clear to you. At omega equal to 0, you will get 1 here also, At omega equal to 0, you will get 1 here also, but at omega tends to infinity. If I talk about omega tends to infinity here you will get again a constant value. At omega tends to infinity here, you will get plus infinity value. At omega tends to infinity, it will approach to 0. So that is why it is not correct, only option number C correct. Only option number C for Chennai correct. Tell me, pyare bachcho, yes or no? Yes. So I think now I will ask JP sir to, and he will solve the questions of network. I think he will solve the question of network. Okay guys, meanwhile you can also share your experience in the chat box. DFT question data is not there, beta. Sampath Babu, can you please share the data? Can you please share the data with us? Meanwhile, some questions analog also. So Gopal sir will come and solve analog questions also. Yes, yes, Gopal. You can come and you can solve here only. We have slides
Okay, sir.
in the background. Okay. And take the mic. Yes. Yes. Start.
But already I have done 3 questions from the 3 or 4 questions I have done from analog circuits. There is one more problem that I want to do now. But in this particular problem, it is given, this is given problem like this now. There is an op amp. By using the op amp, it is given one more question. Here given more importance to the operational amplifier in the iron paper. The V0 is here now, the positive terminal is connected to the ground, and here connected with 1K resistor, R is given 1K. And this is connected with V in, and also connected with one capacitance of the capacitor. Its value is given as a 2 microfarads. C equal to 2 microfarads it is given. And also in the problem it is given the input voltage, what is given? The input voltage is given like this now. The waveform is given like this. This is V in. The shape of the waveform is given like this. This maximum voltage is given 5 volts. And the time period is nothing but the time period. This is given as a 1 millisecond this side. These are all in milliseconds only. Milliseconds it is given. Milliseconds. That's given 1, this is given 2 milliseconds. But it's asking to find V0. V0 is required at 2 milliseconds. At 2 milliseconds I want. V0 at 2 milliseconds is required by using this question. How we can find? How to find this means, but this is the circuit is nothing but integrator circuit only now. By using these integrator circuits, we can find what is V0. V0 is taken minus 1 by C. From the integrator, you know, minus 1 by C integral V in into dt, RC into integral V in into dt only now. This is the formula you know very well. V0 value. Yes, R is given 1K, C is given 2 microfarad, input voltage is given this waveform. We can find. Initially, we can find the what now V0. First, we can take this as a what? V01 we can assume for example. V01 is nothing but V0 formula is general formula is this now. But initially what I wish to say from 0 to 1 I wish to find the what now? Output voltage. Output voltage what is available in between 0 to 1. Then after 1 to 2 I can find here now. I say T is greater than or equal to 0 and less than or equal to 1. I want to find the V0 here now. Its value will be minus 1 by RC. R is given 1K here, 1 into 10 power 3, and C is given as a 2 microfarads, 2 into 10 power minus 6. Input voltage is given here now. How much it is given? 5 voltage is given directly. That voltage I can put 5 into dt, and the limits are to be taken from 0 to 1 here now. But 5 into dt is nothing but the 5t, t equal to upper limit 1, and this finally it comes as a what? To 10 power 3, 10 power minus 6. Finally, this V0 will be minus 2 power 1 millisecond here now, 1 into 10 power minus 3. But on simplification, this value will be minus 2.5 voltage possible here now. Minus 2.5 voltage is possible. I will write here now, you watch. But integrate and substitute the limits only now, understand now. 5 into t, otherwise I will write now 1 into 2 into 10 power minus 3, I will get here 5 into t. And t is taken limits of 0 to 10 power minus 3. And finally, this value comes as a minus 2.5 volts. Minus 2.5 voltage is possible. I am getting the V0 value between the limits of 0 to 1 only now. But between 1 to 2, we cannot find any voltage here now. There is no change. Same constant voltage is going to remain. Output voltage will be same. That means what I wish to say, but T is, I want to take T is greater than or equal to 1. And less than or equal to 2, the V0 remains same value. V0 remains same. Remains same only now. V0 remains same. Even the input is a 0 voltage, output is going to remain same voltage only now. That's why we can take directly V0 is to be taken as a minus 2.5 voltage only. This is the required answer for this question. I hope you followed here now. That way we can tackle this now, understand now. The problem is not tough. If you know the formula for the integrator, you can directly apply and you can get answer. Yes, one student gave here now minus 2.5, exactly correct. This is the solution only now. అది కొంచెం టైట్గా ఉంది.
Hello students, now we will discuss regarding one question which is asked in from the subject network theory, right. So this is the one of the very important model from the transients chapter. Okay, this is the very standard question which is asked in the instrumentation paper in today's exam, right. So first I will draw the circuit diagram given. So in this question they have given 4 kilo ohm resistor which is in series with one inductor which is having the value 1 Henry, and then here once again 4 kilo ohm resistor. After that you are having one switch here. So they have mentioned the switch direction is at t equal 0 like this. Okay. Here you are having 12 volt source. And here you are having one capacitor, 0.1 microfarad. The voltage across this capacitor is Vc of t. Vc of t. Okay. So in this question they have asked that dVc of t divided by dt at t equal to 0 plus. So whoever solved this question, so please mention the chart, and whatever the answer you got after solving this question, you people can mention. Okay. So I will discuss this question. This is okay. You people can cross check whether your answer is correct or not. Okay. So here, if you observe this particular question, okay, just observe the switch. At t equal to 0 instant, we are opening the switch. Yes or no? At t equal 0 instant, we are opening the switch. That means up to t equal 0 minus. Up to t equal 0 minus instant, the switch is in the closed position, right? So the switch is in the closed position. Here you are having 4 kilo ohm and then capacitor, resistor, inductor, right? So for this particular circuit, you are having 12 volt source that was connected. Yes or no? Up to t equal 0 minus, this supply was connected for this inductor and capacitor part of the circuit, right? So first of all, we have to consider the equivalent circuit diagram at t equal to 0 minus. Okay, at t equal 0 minus. So first note down the important points. At t equal to 0 minus instant, the switch was in the closed position. Yes or no? Closed position. switch is in closed position. Okay, so at t equal to 0 minus instant, okay, because this particular voltage source was already connected at t equal to minus infinity. Okay, so with respect to that, at t equal to 0 minus instant, the circuit already reached to the steady state, right? So at t equal to 0 minus instant, circuit is in steady state. Circuit is in steady state. In steady state, inductor acts as short circuit and capacitor acts as open circuit. In steady state, inductor acts as short circuit and capacitor acts as open circuit. Right. Now draw the equivalent circuit diagram. Now draw the equivalent circuit diagram. Four kilo ohm resistor. Now inductor acts as short circuit. Inductor acts as short circuit. Then 4 kilo ohm resistor. 4 kilo ohm, switch is in the closed position, right? Switch is in the closed position. Okay. Then capacitor acts as open circuit. Capacitor acts as open circuit, right? So across the open circuit terminals, voltage is Vc of 0 minus, because we have drawn the equivalent circuit at t equal 0 minus, okay? And the current flowing through this inductor at t equal 0 minus instant is IL of 0 minus, okay? So this is the most important thing. Whenever, suppose at t equal to minus infinity to t equal 0 minus instant, if some independent source already connected to the circuit, in the given circuit, if inductor and capacitor are present, because those are the energy storing elements, at t equal 0 minus instant, circuit already reached to the steady state. Because of that, here inductor acts as short circuit, that means you will get the current, okay? Similarly, the capacitor become open, so across the open circuit terminals you will get the voltage, okay? So first of all, we have to calculate that one. Now here, if you observe, since the capacitor terminals open, there is no current flowing here. There is no current flowing here. If there is no current flows here, now all of you tell me how this 12 volt source, 4 kilo ohm resistor, 4 kilo ohm resistor, all the three elements, how they are connected? Any guess? All these three elements are connected in series. In series, current will be same, but voltage will get divided among the elements, right? So here 4 kilo ohm, 4 kilo ohm, both are having equal resistance. Whatever supply voltage there, half portion you will get here, other half you will get here, right? So that means directly you can write Vc of 0 minus is equal to supply voltage is 12 volt divided by 2, that is nothing but 6 volt. Okay, this is Vc of 0 minus. The same value you will be having even at t equal to 0 plus instant. At t equal 0 plus instant also, same voltage you will be having across the capacitor. Okay, now since all the elements are connected in series current will be same. So IL of 0 minus you can calculate. IL of 0 minus you can calculate. Supply voltage is 12 volt divided by sum of these two resistors, because in series we can add the resistors, right? So 4 kilo ohm plus 4 kilo ohm, directly I am writing 8 kilo ohm. 4 kilo ohm, both are connected in series, right? So here 4 3s are 12, 4 2s are 8. So 1 by K you can write it as milliampere, and 3 by 2 is nothing but 1.5. So you are getting IL of 0 minus as 1.5 milliampere, which is same as IL of 0 plus. This is the most important. Okay. So in general, you have to calculate whenever from t equal to minus infinity to t equal 0 minus, if some independent source already connected, then you have to calculate the initial voltage across the capacitor and initial current through the inductor. The same values you will be having even at t equal 0 plus. Okay. Inductor current cannot adjust or cannot change instantaneously to different value all of a sudden. Similarly, the capacitor voltage, all of a sudden it won't change to the new value, right? So whatever the value you're having at t equal 0 minus, same value you'll be having at t equal 0 plus with respect to capacitor voltage, with respect to inductor current. Okay. Now we have to consider these initial currents. Okay. Now just observe the circuit. Okay, just observe the question. They are asking dVc of t by dt at t equal 0 plus. Now draw the equivalent circuit at t equal 0 plus, and from there let us try to calculate this one. Okay. So now let us draw the equivalent circuit at t equal 0 plus. At t equal 0 plus instant, here the switch was already open. Yes or no? Switch was open. At t equal 0 plus, switch is in open position. Switch is in open position. Okay. And whatever the inductor capacitor behavior earlier we have discussed in steady state, exactly opposite we have to consider. Yeah, SK, you are getting final answer 50 now. Okay, just cross check, after that also you will get some number. Okay, continuation you will get. So here at t equal 0 plus, inductor acts as open circuit, whereas capacitor acts as short circuit. Exactly opposite behavior. Okay, in steady state inductor acts as short, now it will become open. Earlier capacitor in steady state acts as open, now it will become opposite, it is like short. Okay, now let us draw the equivalent circuit at t equal 0 plus. Okay, so here 12 volt 4 kilo ohm, then 4 kilo ohm. So inductor acts as open circuit, but here we got the initial current through the inductor, right? Okay, initial current through the inductor we got, right? So this initial current we have to connect in parallel to the inductor, that is 1.5 milliampere. Okay, 1.5 milliampere. This is the initial current through the inductor. See, this part of the circuit is the equivalent circuit with respect to inductor. Okay, next here the switch was open, right? So 4 kilo ohm resistor, and here the switch position is open. Okay, after that here you are having capacitor. Now capacitor acts as short circuit. Yeah, SK, I will disclose the answer in shortly. Okay, so here capacitor acts as short, but here just now you got the initial voltage as 6 volt. This 6 volt source we have to connect in series with the capacitor. Okay, so this is the equivalent circuit with respect to capacitor, this is the equivalent circuit with respect to inductor. Okay, right. So now this is the circuit diagram at t equal to 0 plus. So at t equal 0 plus, the current flow through the capacitor is IC of 0 plus. Okay, here the terminals become open, that means there is no current flowing here. In this particular branch. Okay, if you carefully observe, here already terminals become open, there is no current. So that means here 1.5 milliampere is entering, right? So since in this branch there is no current flowing, whatever 1.5 milliampere is coming here, the entire current will flow through the capacitor, right? So IC of 0 plus is equal to 1.5 milliampere. Now write the formula regarding current flowing through the capacitor. So IC of t equal to C into dV by dt. So this is the generalized formula, the current flow through the capacitor, right? So from here just rearrange this equation, dVc of t divided by dt, which is equal to IC of t divided by C. Okay, now just observe the question, dVc of t by dt at t equal 0 plus they are asking, right? So now you can substitute. Now you can substitute at t equal 0 plus. At t equal to 0 plus, at t equal to 0 plus, dVc of t by dt is equal to, here in place of t you can consider 0 plus. Yeah, sure. Okay, Ic of 0 plus divided by C. Okay, so here Ic of 0 plus is nothing but 1.5 milliampere divided by capacitor value, how much they have given in the circuit, 0.1 microfarad, right? 0.1 microfarad. So here 1.5 divided by 0.1 is nothing but 15. Okay, here micro you bring to the numerator, it will become 10 power 6. 10 power 6 into 10 power minus 3, you will get 10 power 3. That means 15,000. 15,000. Here left hand side if you observe, volts you are having, voltage you are having in the numerator. So the corresponding units are volts. Denominator you are having time, time units are seconds. So the answer for this question is 15,000. I hope it is clear for everyone. Okay. This is a very interesting question. The final answer is regarding dVc of t by dt at t equal 0 plus is 15,000 volts per second. Okay. So now let us discuss one simple question which is asked regarding digital circuit subject in the GATE instrumentation paper today. So this is the question related to the digital circuit subject. Yeah. So here they have given the Boolean expression like this: F equal to A plus A bar B plus A bar into A plus B bar into C. Okay, they are asking just the minimized function regarding this particular function. They are asking in the simplified form. Okay. Yeah, as of now we haven't get any questions from our students regarding transducer. Once if any questions come, our faculties will discuss. Okay. So whatever the memory based questions we are receiving from the students, we are discussing the questions accordingly, right? So all of you can watch the session, okay? And if you people are having any question, memory based question regarding any subject, you people can mention in the chat also, or even in our Telegram group, you people can share your question so that our faculties will check that question and will provide the solution. Okay. So here you are having, see, you can easily simplify by using distributive law. This is the standard formula derived from the distributive law, right? So A plus A bar is nothing but 1, so you will get A plus B. Okay. Now here you can multiply A bar with these two. A bar into A, you will get 0 plus A bar into B bar into C. Okay, so A plus B I am copying as it is. Then from here you are getting A bar, B bar, C. Directly I have written. Okay, now here if you carefully observe, just like here A plus A bar into B, right? Similarly here A plus A bar into something, you can consider B bar C is something like X. Okay, once again you can apply distribute law. A plus A bar is 1, so you will get A plus B bar C. A plus B bar C. Now this B you can copy as it is. Once again same formula. Here A as it is, B plus B bar is 1, so you will get B plus C. So the final answer for this question is A plus B plus C. Okay. So thank you everyone. So now Vipin sir will discuss further questions regarding instrumentation paper.
Thank you, JP sir. So students, I have few questions. Okay, so first two questions that I have were really easy. So let me discuss those. Just see this question I have, in which this is from measurement. So VT was given, voltage, which is 95 plus. Let me increase the width of the pen. So we have VT, which is 95 plus 200 cos 120 pi t plus 90 cos 360 pi t minus 60 degree. Okay, and the current is given. The current is 4 cos 120 pi t plus 15 cos 240 pi t minus 75, and we have been asked to calculate the P average value. Okay. So this question, normally this topic I used to cover during the fundamental classes. So if you have to cover the P average, and both voltage and current, they are periodic but they are sinusoidal. Sorry, they are periodic but not sinusoidal. So what you have to do? Just see, this is the DC component. We don't have a DC component here. This is 120 pi t component. Do we have 120 pi t component? Yes, we have. This is 360 pi component. Do we have that component? No. Okay. So only those components of voltage and current will contribute in power whose frequency matches. Okay. So if we have to calculate P average here, what will be the P average? The P average will be Vrms. Okay. So what will be the 120 pi? This is 120 pi frequency term. Okay. So what will be the RMS value of that? It will be 200 by root 2. What is the RMS value of 120 pi t terms of current? It will be 4 by root 10. What is the angle between them? Just see. What is the angle between them? I think I am missing some data. This is 120 pi t plus 60. Okay. This is 120 pi t plus 60. So what is the angle difference between them? Cos of 60. Okay. So just see what we will get here. 200 by root 2. 4 by root 2 into 1 by 2. So how much we will get? Just see. We will get 200 watts, and that will be the answer to this question. So only those components, what will be the cutoff, sir? Expected cutoff will be around 30 marks. The level of paper is telling that the expected cutoff will be around 30 marks. Okay, Plani. So this question, I think it was a very easy question. Each one of you could have solved this question. The next question that I have, in which it is also very easy, okay, and it is also from the fundamental. We have been given the current value 4 plus 30 cos t minus 20 sin t plus 15 cos 3t minus 10 of sin 3t, and what we have to calculate here is what will be the RMS value of current. So we have DC component, we have fundamental frequency component, third frequency component. So in such a case, what we have to do? Okay, in such a case, if suppose you have to find the RMS value, that will simply be equals to, and just confirm whether the data is correct. If suppose any problem is there in the data, just confirm me. Okay, so it will be 4 square plus what will be the RMS value of this component? So that will be 30 over root 2 square. What will be the RMS value of this term? 20 by root 2 square. And for this term it will be 15 by root 2 square. And for this term it will be 10 by root 2 square. Okay. So this is DC component, RMS value of it is square. Fundamental component, RMS value of it is square. Like that you will be squaring the RMS value of each and every component, and then you will finally take the root of it, and then you will get the final answer, which is 28.7 ampere. Okay, so these two questions were very easy. Okay, I hope you are getting the same answer, Anil. These two questions were very easy. Now we have one more question from measurement. Okay, so from measurement, so I have one question from measurement in which we have this bridge, and this is the value of Rx which we have to find. Here we have a galvanometer, okay, like this. So this was the bridge given. I hope you all must have solved this question. This was very easy. You don't have to bother with your pen as well. Okay, so this was the bridge, and it is given that the current in the galvanometer, this is the galvanometer, and the current in the galvanometer is 0. You have to find the value of the resistance Rx, and all these values were given 40, this is 40, and this is 60, this is 60, and this was also 60, and this was 90. Okay. So just see guys, 28.8. Yes, Anil, your answer was absolutely correct. Just see, the current in galvanometer is 0, and if you just look into this lower bridge, okay, just look into the lower part of the bridge, isn't it forming a balanced bridge as well? 40, 40, 60, 60. So it will be like 40 into 60 equals to 60 into 40. So the bridge is balanced. The lower bridge is also balanced. So what will be the current here? The current here will also be 0 ampere, isn't it? So there is no current flowing in this branch, no current is flowing in this branch. So we can simply apply the bridge balance condition, and it will be Rx into 60. This will be equals to 90 into 40. So from here Rx will be 90 into 40 upon 60. So what you will get? 60 ohm. I hope you got this answer. Very good, Anil. You got 60 ampere. Very good. So this is also correct. Okay. So this was a very easy question from measurement. I have another question from measurement in which we have been given a bridge like this, in which this is 500 ohm and this is 1 Henry. Next branch that we have is 1000 ohm, and then we have another branch in which R and C were given, and then we have this branch in which the resistance was 1000 ohm. Okay, 1000 ohm. Then we have to find what will be the value of C. Okay, is this the question? Just confirm. Anil, you have been asked the value of C is what you have to calculate. So is this the question? This formula is not valid because same frequency operate. Which formula you are talking, Raju? Focus on this question, whether this data is correct. Okay, and I think frequency was given. You are talking about this question. Frequency was given 5000 radian per second. The data is correct. Okay, so you have to calculate the value of C. So if you will apply the bridge balance condition, so what will be the impedance of this branch? It will be R plus 1 by j omega C. And what will be the impedance of this branch? R plus j omega L, and the data is given. So we can write 500 plus j 5000. Okay. So if we apply the bridge balance condition, what will happen? R plus 1 by j omega C and R plus j omega L. This will be equals to these two branches which are having 1000 into 1000 ohms value. Okay. So from here R plus 1 by j omega C, that will become 1000 into 1000 upon R plus j omega L, or what you can write R minus j upon omega C, that will become 1000 into 1000 upon 500 plus j 5000. Okay. Now you just have to adjust this. Okay, and when you will adjust this, it will become 2000 1 minus j10 divided by 101. So what will be the value of R? It will be 2000 divided by 101. You have to just compare the real and the imaginary part. Okay, they are orthogonal signal. So RMS value direct calculated. Yes, Anil, you are right. Okay, so from here it will come 19.8 ohm, and when you will compare the imaginary part, so 1 upon omega C, that will be equals to 2000 divided by 101. Okay, so we may also write it 1 by 5000 C. So when you will compare it, the C value that you will get is 10.1 microfarad. Okay, yes, Anil, you are right. For the calculation of RMS value in that fashion, the signals has to be orthogonals. Okay, so they were already orthogonal given, so we can calculate that. So just see these two questions for measurement. I hope you have solved these questions, and these were easy questions. So were you getting this answer? What was asked in this question, R or C? Raju and Anil, can you confirm? What was asked, R or C? And if C is asked, you are getting 10.1 microfarad, or R is asked, you are getting 19.8 microfarad, sorry, 19.8 ohm. Okay. So these two questions from measurement, I found them very easy. Okay. So just see, these two are related to power and RMS calculation, and these are from measurement. Okay. So how was your paper? Is it fine? Cutoff, expected cutoff might be around 30 marks. Okay. So now I would like to call Ankur sir to discuss one more question related to. Acha, both were asked. Very good. It was MSQ type of question. So you are getting this answer. If you are getting this answer, you have just nailed this particular question. So I would like to call Ankur sir to discuss one more question of signals. Ankur sir. Transfer karo. So student, now Priyanka ma'am will come and she will discuss the questions of GA and mathematics. Okay.
Hello everyone, welcome again. So dear students, yeah, I'm having few questions of engineering mathematics and aptitude. So let's start with the, please confirm first of all audio video is clear or not. Please confirm. The audio and video is clear, right? Okay. So now I'm having few questions from maths and aptitude. So let's start with the aptitude. Okay, so one question I'm having from the probability, that was the easy question also. Okay, but the language is little bit lengthy, so I'm writing the question for you. So the question is, there are 16 teams. There are 16 teams total. Okay, with the two pools, pool A and pool B. There are total 16 teams. Okay, these in a Premier League, these teams are divided into two pools of 8 team each. So here the 8 team, here also the 8 teams of pool A and pool B. Okay, further in pool A there are 4 teams with red logo and 4 teams with blue logo. So here we are having 2 in this one with the red logo, and here we are having with the blue logo. All right. So when we will go for the next, similarly here in the red, there are 4 teams with the red logo and 4 with the blue. When I will talk about in the pool B, so we are having again red and blue, but with the data is different. So in this case, in pool B there are 5 teams with the red logo and 3 teams with the blue logo. All right. Now what the question is asking, if final is to be held between one team from each pool, means pool A and pool B, only one team is possible. So find the probability that the team with different logo will play the final. So we need to find out the probability the team with the different logo will play the final, and very easily we can just solve this question. So first of all, whatever is written, I want to write down here again as a solution. So there are total 16. Now you can go with the 2 teams. This is your team A. Okay, this is your team B. Every team has having 8 candidates. Okay, or 8 teams. They are having in this one 2 colors, red and blue, and they are having also 2 colors, red and blue. All right. So in this one, 4 each, 4 here and 4 here, in this one 5 year and 3 year. We need to find out the probability one from each. So this is very simple question from the probability. You just need to read the question very carefully. So how to approach? First of all, you can write down here the possible cases. You can write down here the possible cases. What is the possible cases? Either from the team A, means pool A, red team will be there. Okay, red logo team will be there, and from the team B, blue logo will be there, right? It's, you are saying only one from each is possible. So from pool A, only one team is there, and from pool B, only one team is there in the final, but with the different logos. So here you can see very easily that team A, either you can see red. So I am writing here the possible cases. So from team A, red logo is there, okay, and from team B, blue logo is there, or we can go with the or. Either in this team A we can see the blue logo, and in the team B we can see the red logo. So here team A with the blue one and team B with the red one. This is very simple, and you need to write down the probability. So what is the probability of being red logo? You can see total you are having 8. So probability of red will be 4 by 8. Probability of blue will be again 4 by 8 in the first case. When we talk about here, so we can write down the probability of red in this case is 5 by 8, 5 by favorable by total, and here in the blue it will be 3 by 8 favorable by total. Alright. So yeah, very good, shabash Vikram. So when we will solve it, so we can write down this is the first case, to probability 4 by 8 into, and will denote the multiplication, 4 by 8 into 5 by 8, okay, plus the next will be OR. So OR will denote the addition, plus 4 by 8 into 3 by 8. When you will solve very easily, you can go, this will be 20 by 64, this will be 12 by 64, means 32 by 64, 32 into 2 will be 64, so 1 by 2 or 0.5. If this was a NIT, then your answer should be 0.5. Very easily you can write down the solution. I hope it is clear. Very simply we can write down. Okay, now we are having more questions. 3-4 questions were there which has been asked in the civil afternoon session also, which we discussed here only in the civil. Just few minutes ago we discussed in the civil, and those question has been asked in the instrumentation also. So I am going to write down among them few questions which are very easily we can approach. So this was your first question earlier. This was your first question from the general aptitude. Now the next question from the general aptitude, very simple question we are having, that is find the sum of the 20 consecutive. Find the sum of, okay, what we need to find out, find the result if the sum of 20 consecutive odd integers, okay, divided by 20 square. You guys can confirm the data also, divided by square of 20. So very easily we can solve. We know very well this is nothing but sum of odd natural numbers. You can go with the sum of odd natural numbers. Sum of odd natural number, the formula directly we can use, that is the n square. Okay, if I will go with this one, sum of odd natural number, first odd natural numbers, it will be first n natural first n odd natural numbers. So I am having here at the place of n is 20 only. So you can approach, the result will be 20 square, and you need to divide this by the 20 square again. So 20 square by 20 square, your result will be 1 in this case. Your result will be 1 in this case. Yeah, very good, shabash Kaushik and Vikram, absolutely right. And when we go for the next question in this segment, so we are having the question from the student mistakenly, the student supposed to do the product PQ. The student supposed to do the product PQ, but by mistakenly he did divide P by Q. So he need to do the product, but by mistakenly he did the P by Q. Then in this case, the percentage error he found, or in this transaction the percentage error was 80%. Okay, so then you need to find out the value of Q. You need to find out the value of Q. I hope the question was this one only. as my throat is not so good, so my voice will be not so much clear, but still if it is audible, so you guys can confirm also about the question. Yeah, very good. Okay, the value of Q. So here let's see what happened. So we can write down very easily. You are saying he did product as he need to do the divide. So he need to do the divide, but he did product. So let's approach here. So we write down very easily. The percentage error will be the initial value minus final value divided by initial. So PQ minus P by Q divided by PQ, and this is given to you already 80. So this and 100, I can write down this equals to 80. P will be gone. When you will solve, this will be Q square minus 1 by Q square is equals to 80 by 100, which is your 4 by 5 only. Okay, and when you will solve it, you can write down this will be Q square by Q square minus 1 by Q square is 4 by 5. This will be gone, hence I will go for 1 by Q square is 1 by 5. So you are looking for the value of Q, which will be square root of 5. Very easily we can approach this one also. Right, correct question. Thank you for the confirmation, Vikram. So very easily we can go for the result will be square root of 5, and very simply we can approach it. All right, and if I'm not wrong, the one question is here from the number of boys and girls also. So let's approach that one also. Let's go for that question, number of boys and girls. So what was given to you? The ratio of number of boys, ratio between number of boys of class 8 and number of girls of class 8, okay, is the same as this ratio is the same as number of girls, it's opposite, number of girls of class 8 to number of boys of class 8, okay, and number of boys to girls here. So number of boys of class 9 and number of girls of class 9. Okay ji, this is given to you 200 girls. Yeah, absolutely right, very good, Ridin, shabash. So here what the question is saying, total number of students in this class. Acha, total is also given to us. Total in the class 8 is 450, total in the class 9 is 360, and one more relation is given to you. Number of girls in class 8 is equals to number of girls in class 9. This relation is also given to you. These things are given, and the question is looking for find the number of girls in each class. Each class means the number of girl is same in 8th class also and in the 9th class also, so it will be same. So we need to go for the number of girls same, it should be same. So let's approach it very easily. We can approach here. So what is given, we can start from the ratio. Acha, before approaching this, let us assume, I'm writing here so it will make your question very easy. Let us assume the number of girls in class 8 as an X and number of girls in class 9 as an Y. When I'm saying number of girls in class 8 as an X, so the boys in class 8 will be total minus X, so which will be 450 minus X, and boys in class 9 will be again total minus Y, so that will be 360 minus Y. Now we can use the relation, so that I'm assuming, and now we can use the given relation. So when I will use this one, so girls to boys means here you can go with X by 450 minus X is equals to 360 minus Y by Y. This is given to us. Let's solve by the cross multiplication and the question will be done. So XY equals to 360 minus Y multiply with the 450 minus X. Alright. So when you will open, this will be XY. When I will multiply the numbers as 360 into 450, we used to approach like this in the classroom also. Whenever we are having these type of question, you should not solve all the things all together. Just hold it. Maybe something will be cancelled out, then we will solve it. Okay. So that's why I am not multiplying this one. So 100% here some datas will be cancelled out. Minus 450y minus plus xy. I can see xy will be gone from here. So when you will approach here, let's take these two values to there. So 360x minus plus 450y equals to 360 into 450. Now one relation was given to us now, number of girls in class 8 is equal to number of girls in class 9, which I take x and y. So I can use this relation that x is equals to y, bachcho, right? So when I will go for this one, x is equals to y, so here I will put the x. So when I will here I will put the x. When I will solve, this will become 810x is equals to, let it be as it is, 360 into 450. 0 will be gone, this will be 9 times, this will be 5 times, this will be 4040 times. So hence your x will be nothing but 200. Your x will be nothing but 200. So you are looking for the number of girls in the class 8 or you are looking for the number of girls in the class 9. The result will be 200. Yeah, isn't it? Shabash, Himanshu and Ritin. Already you guys confirmed. So very good this is. So which I am having right now, these 3 questions from the 3 and 1, 4 questions from the general aptitude. Okay, one very simple question I am having from the engineering mathematics also. So let's go with that question also. If you guys are having the question, as I told you earlier also, if you guys are having the question, you can just send us, so that as early as possible we receive the question, we go for the solution. Okay, now right now I'm having one question. So let's see if the eigenvalues, you guys can confirm the datas also of the matrix A is 1 by 4, 1 and minus 2. Please confirm whether this thing is given or not. So if the eigenvalues of the matrix A is 1 by 4, 1 and minus 2, and it is asking about, then find the eigenvalue of, this is similar pattern of question already asked in the GATE exam earlier, eigenvalue of determinant of the A inverse. Find the eigenvalues of determinant of A inverse. Yeah, you can send through the telegram beta, you can send directly to the telegram, as our telegram group is mentioned there, so you can just send it to the telegram. Yeah, the correct data, very good, thank you. Okay, so now let's approach it, let's solve it. So here when I will go with this one, so very simply we can solve, as we know very well, whenever we will go like this one, so the determinant is nothing but very simply we can approach, and lots of the questions 110 times, more than 100 times we solve these type of questions. Okay, so the determinant is nothing but product of eigenvalues. Very simply we can approach product of eigenvalues. So product of eigenvalues, if you are having 1 by 4, 1 and 1 by 4, 1 and minus 2, right? 1 by 4, 1 and minus 2. So the product when you will go, so this will be minus 1 by 2. This is my determinant. Now this is the determinant when you want to approach here. So how to solve the thing? So this is the determinant minus 1 by 2. You need to find out the determinant of A inverse. So determinant of A inverse is nothing but 1 upon determinant of A. So 1 by minus 1 upon 2. So hence your answer should be minus 2. Bachcho, please confirm. Your answer should be minus 2. Isn't it? In the question they asked about determinant of A inverse. So that's what I am writing now. Determinant of A inverse only. Determinant of A inverse only I am writing. Vikram, please confirm. Yes, I hope this is clear. Okay. So you guys can confirm about this one also. As today we are having the questions which were the memory based. Okay, I will go for the more questions. I will find out anyhow for you guys the more questions. Okay, and once I will confirm the data in this upcoming week. In this upcoming week means before the next weekend, 9th, 10th and 11th. I will come live. Okay, on our YouTube channel only, in this channel only, I will come live with the all questions of DA, Civil, Civil 1, Civil 2 and the today also IN. So I will come with these papers, mechanical is also there. Okay, so I will come with the questions of general aptitude and engineering mathematics especially, so that every student who is going to appear in the next weekend, so they will have an idea that how the questions was there, how the question can be framed in the maths and aptitude. So it will give you clarity that which topics you need to focus more. Alright guys, so in the upcoming week means from the Monday to the before the Saturday, so Monday to Friday, very soon, as early as possible, it is possible, okay. If it is possible for me, I will come tomorrow. If it is possible, day after tomorrow. So as early as possible I will come live with all the questions of this weekend, including all the branches, DA, civil, mechanical, okay, civil 1, civil 2 and the IN, with the maths and aptitude questions togetherly, so that every student have an idea, because this is very important thing, that what type of questions we are having. The syllabus is same in the maths also, in aptitude also, more or less 1 and 2 topic are not there. So if we talk about, especially in the general aptitude, you should know, because the weightage is 15 marks, you should know how the questions will be there, how the questions is making, okay, how they are asking the question with the language. So every idea you can get by just having these questions, okay. And already we already approached here in this YouTube channel only. You can see recently in the last weekend only, we just discussed the marathon session of engineering mathematics. Also we had the marathon session of general aptitude also, where we revise each and everything. So in terms of the revision you want to see, you can just use the previous past live links there. And in terms of the questions, I will come very soon in the live. Alright guys, okay ji. So that's all from today's session. In the next weekend also we will be live on the 10th and 11th, both days we will live for the EC electrical, okay, and CS students also. So we will be live with the detailed solution. Not only the detailed solution, we will provide the analysis also, how the cutoff will be there, okay, what we can expect the cutoff, how was the paper level, with the detailed solution. So everything we will be provide again on the next weekend also. So for better, you guys can just subscribe our YouTube channel, you guys can join our Telegram group, okay, as the details of the Telegram groups are mentioned here. So you can just join our Telegram group also. Here this is the detail of the Telegram group, you can see. I missed something. Yeah, here only. This is the detail of our Telegram group. So you can join the Telegram group, where we can have the idea, okay, you can have the idea whenever the live class will be there, you can join on the time, and you can just get benefit of each and every live session of analysis plus the detailed solution also. Alright guys, chalo, bye bye, take care, good night all of you, all the very best for the next weekend. Before that we will meet in the live class. Till that, bye bye, take care, thank you all of you.